C3 Exponential and log functions, example 1. Before attempting this example, make sure you have fully read the notes on the first 2 pages leading up to this example. So for this example, we need to sketch the graph of 1 minus e to the x. From the previous notes, you should be familiar with this number e and the shape of the graph e to the x. It's just an exponential graph, and you should be familiar that e is a number approximately 2.8. So let's get this graph drawn. 1 minus e to the x. There's some transformations going on here. First of all, the minus in front of the e to the x. That's going to be a reflection in the x-axis. If it was e to the power minus x, that will be a reflection in the y-axis. So first of all, I'm going to reflect this graph in the x-axis. So make sure you always label your axes. They're not always going to be x and y, so we must label them every time. In this case, they are x and y. So e to the minus x. Let's just remind ourselves what the e to the x graph looks like. This pen is going to disappear in a moment, but that's the general shape of e to the power x going through the y-axis at 1. So minus e to the x, I'm ignoring the 1 for now, minus e to the x, a reflection in the x-axis. So it's going to look like this time going through the y-axis at minus 1. Now let's consider this 1, because this isn't the finished graph. I'm just going to rewrite f of x like this. Minus e to the x plus 1. That's the same as the question. I haven't changed anything. We've still got 1 minus e to the x. Writing it this way, hopefully you recognize this is going to move the whole graph up by 1 unit. Any asymptotes will go with that. So let's get it drawn. Minus e to the x went through the y-axis at minus 1. If I then shift the whole graph up by 1, this will go through the origin. Now I mentioned there'll be an asymptote. There is an asymptote for the e to the x graph on the x-axis. So then when we reflect in the x-axis, it stays where it is. And then moving it up, the whole graph up, the asymptote will go with it. So I'm going to draw the asymptote first. And that's a good bit of advice. If you have any asymptotes, draw them first. So it goes through 1 on the y-axis. So now for the graph, 1 minus e to the minus x. So it comes from the asymptote. I'm going to go through the origin. I'm just going to redo that. Goes through the origin. Goes down to minus infinity. It's a bit of a messy graph. Try and do it as smooth as I can. One more time. So it comes down. It's always decreasing, going down, and goes down to the origin. I'm struggling to draw it accurately with this pen, but make sure when you draw it you have a nice smooth curve going through the origin, going down to minus infinity. So that's the graph of 1 minus e to the x. State the domain and range of the function and any asymptotes. Well, here's the asymptote, y equals 1. Domain and range. So the domain is the set of numbers which we can put into this function. Now we can put any number we like into this function. So the domain x is any real number. X is a member of the real numbers. And for the range, we'll look at the y values on my graph. Well, the lowest y value, well, there isn't one. It goes down to minus infinity. The highest y value, you might say, is 1, but actually it's an asymptote. It never actually gets there. So it's like a ceiling, a limit. So the range, y is any real number, but y is always smaller than 1. Not equal to 1, because it's an asymptote, it never actually touches 1, and there's certainly nothing above 1, so the range, any real number smaller than 1. And that's the end of example 1.